Alright, well, let's go ahead and look at our new unified Moose workflow item. First off, right now we're in the default ICE perspective. When you first open ICE, this is what you should see. We want to go ahead and switch to our specialized Moose perspective with extra views that are important for Moose users. To do that, you just go up to the top right corner and select Open New Perspective over here. And in the drop down there is a Moose perspective. We'll go ahead and select that. And this is what you should see. So we have the console in the Properties tab down here at the bottom. Console for printing out simulation output and things of that nature. Properties for setting Moose tree data and properties for your specific blocks in the Moose tree. And then we have just added this new Project Explorer tab, this view here, which will let you look at the current files in your workspace. And you can really just sort of organize this as you see fit. I like to have the composite or the console view here. Let's move the Moose data tree view over to here. Okay, there we go. I'll move this up a little bit. This is all about what's perfect for your workflow. Okay, I'll move this here, and we'll put these two side by side and make this a little smaller. Okay, drag this up. So now we can see the items we've created, the resources that have been produced from our simulation, all of our files if we want, the console output, the tree, and I'd like to add one more. So we've recently improved the way that users can see progress that's going on in the background. So let's see if I can find that. We'll add progress here. We'll make it its own little area over here. So as long-running tasks get kicked off under the hood in ICE, they will pop up in this progress bar tab view, if you will, down here. So the user's not left wondering, what's going on in the background. Why is this wheel spinning and that sort of thing. And you'll see this view being populated when we launch jobs, when we connect a visit, and so on and so forth. Okay, I like to have that here just so I know what's going on under the hood. So before we get started, we do need to go ahead and create a visit connection so that we can see our mesh and data files and solution mesh files. So to do that, you just want to go up to Preferences. On Mac, it's under this ICE application button. On Linux and Windows, it should be under Window Preferences. So we'll go ahead and click this and go down to the Visualization preference and click Visit. Here is a table of all of our visit connections. We don't have any currently, but if we did have a bunch, we would be able to see them here and select which ones we want to use. Let's go ahead and add one. Okay, and it adds one with the default connection name, a host, which we'll have our visit executable here locally, a port, the OS, and the path. Okay, those are all the important ones. So we'll leave the name. We'll leave all these first three like that. We'll go ahead and say this is Mac OS, and we'll give it the path. Which, if you ran the script, that installed ICE, it's located in there. Otherwise, just point it to your regular visit installation. I'm going to point it to the script that I ran earlier. And visit bin. Okay, so let's expand that so you can see it and hit apply. When I hit apply, you'll notice in the progress view that the visit connection is being created, and we'll be able to watch its progress. Okay, and it finished. Since the progress tab did not open up an error, we know that we have a connection to visit and it is working, and we can go about our work. Let's go ahead and get started with a new Moose item. So before we had a Moose model and a Moose launcher. To improve efficiency and usability, we've condensed those two capabilities into one unified Moose workflow item. Let's go ahead and start it. Okay. And you'll notice that we have our usual parallel execution component where you can specify the number of processes and threads for your simulation. We have our files component where we can specify the name of the output file that we want to create. But we can also now So to hide the YAML data and keep that internal to Moose, we're now allowing users to just specify their application. And to do that, you can actually type in the name of the application here, the actual path, or you can hit Browse, and you can go find it with our file browser. So mine is located in Workspaces, ICE, and I can go ahead and select the Bison one, or I can go ahead and select this test application that I made. I'm going to select that one for this demonstration. Okay, and it sets it as the application, and all you have to do is hit Save. I just hit Command S, and it knows to look at the application and its YAML and action syntax data and create the Moose tree. Okay, and what's interesting is that this drop down, let's go ahead and add Bison, for instance, just so you can see. We can go ahead and click Save there. The tree will change because it's the Bison tree now. And you can just switch back and forth. Okay. Switch back to the test animal app. And what's cool is that this list of applications persists between ICE executions. Okay, so I can quit out of this running instance of ICE, come back in a couple hours, and I'll still have the same animals available for use within the new Moose tools. Okay. So for this demonstration, let's go ahead and create a new problem. Let's make a convection diffusion time-dependent problem. So we need to go ahead and add a few kernels. We need to add 3 kernels specifically, convection, diffusion, and time derivative. You can do that by right-clicking kernels and saying Add Child. So do that. Or you can right-click the green plus button here, say diffusion, time derivative. Okay, and they're all here. So then, for the Properties tab of each of these kernels, we list the available properties for you to set. So first off, we need to set a variable, but look, the variable, we have no variables in our Moose tree, so there is nothing to select. So previously, you would have to, with our old Moose support, you would have to actually enter in the text of the variable name to add that variable to the block. We've changed that to be a discrete list, and that discrete list is populated by the list of variables in your variables block. If you don't have any, we say create a variable. So let's go down and actually do that. To create a variable, just add a child. We'll create a new variable. I'm going to rename it to something more descriptive. Call it temperature, temp. Okay. I'm going to highlight this row of this block here so that I know it's written to file. Okay. Let's go back to our kernels. Now, our kernels have repopulated, the variable entries have repopulated with what's available. And I could add more variables if I wanted, and that would dynamically update on each of our kernels. So let's look. See? I could delete them and it will go away, and so on and so forth. Okay? And this happens throughout the tree. We do this for all variable entries in the tree and all aux variable entries in the tree. Okay? So I'm going to go ahead and select all these to make sure that they're written to file, and they're all working on temperature, so that's good. Okay, let's define our mesh. And I just want to use a very simple file mesh. Okay, I know what it's called. It's called mug.e. And if I check this and enable that block and I hit save, well then in the background ICE is searching that Moose tree for all possible file entries. And when it finds one, it displays it here for the user so that you can set it to something different or browse to it on the file system and bring it into your current default workspace. Okay, so we just added a mesh. Now let's go ahead and add some boundary conditions for our problem. Go ahead and hit add. We'll add 2 Dirichlet boundary conditions. Okay, I'm going to rename them something more descriptive. So this mug has a bottom boundary condition and it has a top. Okay, let's click these to turn them on for our file. We need to name the boundary within the mesh itself, which we named bottom. We'll set its value as 1. And for top, we'll do the same thing. We'll set its value as 0. Okay, so we have our boundary conditions set up. We need to set up our executioner. Let's turn it on. We'll run a transient executioner, keep the time step as 1, and turn it on so it's printed a file. And then we want to go a certain number of steps. Let's go maybe 10 steps. Turn on the solve type. We'll keep it as the PJFNK. And then 2 more things. The outputs. Okay. We'll set Exodus to true, file base to out, and we'll print linear residuals and print the performance log. Okay. Hit save. And to demonstrate our live updating as the simulation is running of post-processor data, let's just add a very simple post-processor. The simplest one I can think of is this nodal variable value. Turn it on. And we'll look at node maybe 50. Okay? And we'll watch its evolution through time as the simulation is running. Okay? So I think we've got our entire tree set up correctly. And all we really need to do now is launch the job. When we launch the job, ICE will automatically specify a new output block for you. And it's a special output that we've developed on a fork of Moose of our own that is it's a subclass of file output, but it's called the ICE updater. And what it does is it uses our ICE internal C++ updater code, which talks to the ICE running instance via WebSockets and communicates post-processor data at given times back to ICE for plotting and display as the simulation is running. Okay, and so when I click Launch, you'll see a number of resources pop open in the Resources view. We will click the post-processor resource in that view and watch the plot update dynamically. Okay. So I'll go ahead and start this job. And see, this is great. ICE has reported an error to me. And this is actually a really simple one to fix. I just forgot a very special parameter in the convection block. I didn't give it a velocity, and it's required. ICE knows when these things are required. So I'll go ahead and specify that really simply. Just give it a vector. Okay. We'll hit save. And we'll launch the job. And it's going. So let's go ahead and click this and watch it update dynamically in time. This is Moose talking back to ICE over WebSockets. Okay? And so now the simulation is over, and you can imagine any number of values that you might care to watch. You know, rod input or rod output power, or fission gas produced. You know, any number of observables about the system. We can show that to you live as the simulation is running now. Okay? Let's look at the output. Okay, I'll just double click that. It'll open up a new plot. Okay, and we could have looked at this before the launch too to see what the mesh actually looked like. I didn't, but we could have. And we can look at any of the variables solution on each node. Okay, and this is just a solution at time step 1. There's a bug currently. We will have a we usually have a time slider widget right here, but due to a bug, we're not showing that right now. But this is a solution. We can look at it and analyze the results. And for simulations with more than one post processor, we could look at all sorts of different plots here. We can make this bigger to look at it in a bigger view, which is nice. Okay, and then we can pop back if we want and rerun it if we wanted to maybe change some values down here and see what happens. Okay. And so this is our updated unified Moose workflow item. It takes the best from both the old Moose model item and the Moose launcher and merges them into one unified interface to reduce the number of clicks for the users to get to their expected simulation output and just do their research faster. So, toward the end of our discussions on increasing usability of the Moose tools in ICE, Andrew Slaughter from the Moose team mentioned that ideally he'd like to see 10 clicks or less. So, can we reduce the number of clicks and have a low click count to go from a user-specified input file to launching the job and looking at the output. And after he sort of made that challenge, I think we all came back to Oak Ridge and said, all right, challenge accepted, we can do this. And so now I'm going to take the Andrew Slaughter 10-click challenge and try to get 10 clicks or less to launch a Moose job and look at the output. So let's get started. I'm going to import an existing item. Okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and just so we can look at something else, 10. And that was the 10-click challenge. ICE now presents a unified interface for the Moose tools that is more usable and efficient and lets users get to their results quicker.